So I want to first of all point out to you that right here it says the 7. That's supposed to be like dramatically says the 7. What is that about? Well, that's about, if you scroll down here and zoom in where it says no, the 7 elements that naturally form diatomic molecules. Well, that's almost what it says. Those are the 7. And if you think back about this, you probably kind of understand what this is talking about. Remember, if anybody's ever talking about oxygen, not the element on the periodic table, but the stuff you breathe, how do they write it? O2. That's what it means. These 7 elements that are highlighted here always come diatomic when you're using them in a chemical equation. Hydrogen always comes as H2. The air you're breathing right now is 78% N2. Fluorine does not come as F in nature, it comes as F2. It forms, all of these things form covalent bonds with each other. They share electrons to fill their octet or duet in the case of hydrogen. And so they always come as diatomic molecules. So that's one of the things we have to know for the test. Are you ready for that? Good. That'll be on the test. The other thing I want to point out, I may have pointed to your class yesterday, when there's this summary of the types of chemical reactions. This calls them classes of chemical reactions. If you look clear down at the bottom, it says, hey, we've got all chemical reactions, but they're composed of 3 things: precipitation reactions, acid-base reactions, and oxidation-reduction reactions. What we worked with yesterday and what we're working with today are the precipitation reactions. These 5 that are right here used to be the way we cover reactions. We're no longer talking about those. We're only talking about precipitation, acid-base, and oxidation-reduction reactions. So, wanted to mention that to you. We went on to look at this page, and we crossed off number 8. You did question number 9. Here on this page, I think you answered everything and have kind of checked with you. So we're moving ahead to, would you please find this page? Now this is where you're going to be using that pink sheet, that list of common ions, because we have a set of rules, and you can either memorize these or you can make a note on your pink common ion sheet. Now, if you happen to be watching this video, you're a rare breed because you're studying outside of class. Thank you very much for doing that. But this has a list of all the ions you might need to use for this class, so you don't have to have them memorized. But you'll notice right here on question 19, right here where I'm underlining, it says, these ions are always soluble in water. So the way you can tell for this class if something is soluble is you can look and say, does it have sodium, potassium, ammonium, or nitrate? So I'm going to encourage you to find those on your common ion sheet. You might want to put your name on it so you have this for later. But we're going to find those ions. So the first 2, potassium and sodium, are right here. So if you put some little note by them so you don't forget, potassium and sodium are the 2 cations from group 1. It turns out that almost everything in group 1 is always soluble, but we're only focused on these 2. There are a bunch of rules you don't have to memorize for this class. We used to memorize a song, and the song really helped. And back when I used to teach those rules, this song on YouTube used to get another 5,000 views every year at this time of year. But now all the AP chemistry classes have just gone to this simpler version, and now they don't have to know things like alkali metals and ammonium salts, whatever they may be, can always be depended on for solubility. When asked about the nitrates, the answer is always clear. They each and all are soluble, that's all I want to hear. So, you're lucky you don't have to listen to that entire song. Thank you. So, yeah, you can go to YouTube and find it under chemistry 98277. Can I what? I can add a link to it. Yeah, and then you can share it, and I can get a few hundred more views, maybe. I don't know what it's up to now. It's not growing as fast as it used to. Okay, so I will try to add that link. So those are the first two. But where's ammonium? By the way, those of you out there in video land, right there are the first two. Ammonium is down here. Ammonium is the only positively charged polyatomic ion that we worry about. That's ammonium. It's right down here. Make a little mark by it. Highlight it. Because that, if you see it in a compound, it is soluble. It is soluble if you see it in a compound. And then the last one for our solubility rules is nitrate. Nitrate is right here by my finger. Nitrate is right here. There, balance the paper. Nitrate, NO3 -1. If you see that, it's soluble. So those are really our solubility rules for this class. And now you have them on your pink common ion sheet, so you don't have to memorize them. Those are the things that make everything soluble. So, when you move down to this, and some of you have done this, some of you are still working on it, so I'm going to help you through it. This says a student only has access to these three chemicals. Well, one of them we've got here. One of them is not soluble according to our solubility rules. AgI, silver iodide, would not be soluble. So right here you notice if it's aqueous, that means it dissolves in water. So the other thing has to be NH4I, ammonium iodide. Ammonium iodide and lead nitrate, when they're added together, something has to drive the reaction forward. Will you remember that term till Monday when you do it on a Kahoot? Because we're not going to get to that Kahoot that was up there earlier. Just not enough time today.
I got that.
Something has to drive a reaction forward or it will not move forward. And in this case, it's that this lead and this iodide that are floating in solution go snap and snap together and release some energy in the process. And so that forms a solid. That forms the precipitate because it's not soluble. By the way, did you notice the chemist's word for not soluble in the work you were doing? What's the other word for not soluble? What? One word. You got to put not soluble together and make one word. Aqueous is soluble. Aqueous is the opposite of not soluble. What was the word they used? Insoluble. Insoluble means not soluble.
So it was close then.
Not soluble, insoluble. So, the potassium iodide is insoluble. The other two ions that are here are ammonium, NH4. Try to make that a little bigger and see if my computer will complain. NH4, NO3. So that is the molecular equation, that's what we call it. The complete ionic equation takes all of those things and just writes them as separate ions. And this takes a lot of space. So when you're doing this, like you're doing it right now, you should start and give yourself some room. There's lead with a charge of +2. There's NO3 with a charge of -1. There's NH4 that we looked at on your common ion sheet with a charge of +1. There's NO3, -1. So those things we were all familiar with, except one thing. How did I know that the lead was +2? You have to calculate that. Now, it's an easy calculation. You don't have to write it out. A lot of you would just do it in your head. But I'm going to go over here and calculate how I knew the charge of lead was +2. Here's the equation. Pb NO3 twice. Was that actually the equation? I have to check here. Yes. So you have this equation. How do I know lead is +2? Well, I want to remind you that the charges of the positive and negative ions have to add up to 0. They have to add up to 0. Now here we have nitrate, NO3, -1, and we have a second nitrate, NO3, -1. That means that the total charge, negative charge, is -2. What's the total positive charge? Well, the total positive charge has to be +2. That's the only thing it can be, is +2. There's only one lead, so that one lead has to be +2. Now, I wrote a lot, but once you've practiced this for a bit, you don't have to write that much to understand that the charge of the lead is +2. So we've got to write an arrow now for this reaction. Then we write ammonia, NH4 plus, and iodide, -1. Uh-oh, I wrote something wrong here. No, I didn't. Okay, good. Whew. I wrote one thing wrong. Yeah, I see it. I'm writing this compound now, and so I need to do NO3, -1. And so now I've written PbI2. That's the stuff that was solid. Our solubility rules say if it doesn't have potassium or sodium or ammonium or nitrate in it, we're going to call it a solid. That's the only chemicals we're going to deal with. So that is the complete ionic equation. So the next thing you have to do is go through and make the net ionic equation. And the way you're going to do that is cancel the things that are the same on both sides of the equation and just write what is left. Pb2 plus, and sorry about that, let's stay out here, computer, stay. Pb2 plus, oh, the NO3 canceled. Oh, I see. I made a mistake back here. This was supposed to be iodine. Yeah, silly me. That's going to mess people up taking notes at home, because that was the iodine. Where was the? There it is. That iodine should have been right there, and I missed it. Who didn't? Why didn't you guys stop me?
We're not smart enough to challenge it.
Makes PbI2 I2 solid. Okay, we're going to cross off number 20. If my computer life.